Good morning. Today we will discuss about the two phenomenon of waves. One is intensity of waves and the other is superposition of waves. That is the most famous superposition theorem. Okay. So first let us begin with intensity of waves. What is the definition for intensity and what is its expression, like that. Okay. So first we will learn the definition. Intensity of waves, that is the quantity of energy incident per unit area of a wavefront per unit time, is called intensity or energy flux of a wave. That is nothing but energy which is incident per unit area per unit time. That's all. Okay. So that give you the definition for the intensity, which is also called as energy flux of the wave. What is it? Quantity of energy which is incident per unit area of a wavefront per unit time. Now, in a progressive way, which we have already discussed in the last class, a new length of the medium, say nu, is set into vibration every second. That is, you have a medium and you are setting vibrations in that medium. How? At an interval of every 1 second. That is, every second you are setting a medium into vibration. In such a medium, the intensity is given by the rate of flow of energy per unit area of cross section of the wavefront along the direction of wave propagation. So, when you set vibrations into a medium every second, what will be the intensity of that wave produced in that medium? Intensity of the wave will be the same as the amount of flow or the rate of flow of energy per unit area of cross section along the direction of wave propagation. So, we can conclude that intensity of wave is the product of the energy density and wave velocity. It is represented by the letter I given by equation 27. This term represents energy density and this term represents wave velocity. So, intensity is a product of energy density and wave velocity. Here V is actually this one is the length of the medium, rho is the density, A is the amplitude, lambda is the wavelength. So from this equation it is very clear that intensity of wave, that is I, is proportional to the square of amplitude of the wave, that is I proportional to A square, right? I proportional to A square. This equation, from this it is very clear, right? That is, intensity of the wave is directly proportional to the square of amplitude of wave. Now, in the case of a plane wavefront, there will not be any change in the amplitude and intensity with distance. That is, a plane wave will always travel without attenuation. Attenuation means disturbance. That is, a plane wave always travels without any disturbance. Why? Because there is no change in the amplitude and intensity with distance. But whereas in the case of a wavefront which is originating from a point source, say like a spherical wavefront, what happens? Intensity obeys inverse square law. That is, the intensity will fall or the intensity will decrease as the square of distance from the source. So if you have a plane wavefront, then the wave will travel without any attenuation. Okay, that is, if it is a plane wave, there is no dependence of amplitude and intensity on distance, so it will travel freely without any disturbance. But if the wave is originating from a point source or from a spherical wavefront, then what happens? Intensity will decrease. How it is decreasing? It will decrease as the square of distance from the source. Next is the superposition of waves. Now this principle of superposition, we can apply this to waves when two or more waves travel through a medium at the same time. So this principle is applicable only if, which are the conditions? We must have two or more waves and that waves must travel through the medium at the same time. Okay, so those 2 points are the highlight. For this principle to be valid, you must have two or more waves traveling through the medium at the same time. Now, what does this theorem states? According to this theorem or principle, if two or more waves travel through a medium at the same time, the resultant displacement, okay, that is the net displacement at a particular point will be the vector sum of displacement due to individual waves. That is, why if y1, y2, y3 are the displacement of particles in the medium due to the waves 1, 2 and 3, then the resultant displacement of the particle is given by y is equal to y1 plus y2 plus y3. They have written it very clearly, so I hope the statement is clear to all. That is, if you have two or more waves traveling through a medium, then the final displacement or the resultant displacement at a particular point will be the vector sum of displacement due to each individual wave. So here they have given that if y1, y2, y3 are the displacement of each particle due to the waves 1, 2, 3, that is y1 is the displacement of particle due to wave 1, y2 is the displacement of particle due to wave 2, y3 is the displacement of particle due to wave 3. Okay, if y1, y2 and y3 are like that, then the resultant displacement of the particle will be the vector sum of all those, that is it will be y equal to y1 plus y2 plus y3. So that is the superposition theorem. Then next, so these waves are that we are considering, that is we have already said we are considering some individual waves. All these waves are assumed to be linear, and the waves pass through each other without being disturbed. So these are a few assumptions that we make, that is the waves that we are considering for superposition theorem are linear, at the same time they are traveling without any disturbance. Then here in some cases there occurs a phenomena called interference, that is these waves may sometimes interfere with each other. Okay, that is what they are talking about, that I have underlined. If the waves that we are considering here are of same frequency and amplitude, and if they are traveling in same direction, that is coincident wave trains, the resultant will have twice the amplitude when the individual waves are in phase and motionless situation when the waves are out of phase. So it is nothing, I will make it more clear. That is, so here in superposition theorem we are making two assumptions. One is the waves are considered to be linear and they are traveling without any disturbance. Now suppose that the waves that we are considering are of same frequency and amplitude and they are traveling in same direction. In such cases, the final wave, the resultant wave, the amplitude of the resultant final wave will be twice as that of the individual waves. Okay. Now what happens when these individual waves are in phase? This happens only when these individual waves are in phase. Okay, and there will be a motionless situation when the waves are out of phase. So we are having two, suppose that you are having two waves, they are having same frequency and same amplitude and they are traveling in same direction. Okay, so let them interfere with each other and you will get a final resultant wave. The amplitude of that final resultant wave will be the twice of the amplitude of the individual waves. Okay, provided all these waves are in phase. Now what happens if the waves that we are considering is out of phase? There will not be any movement. It will be a motionless situation. That is what they are trying to explain. So I will brief these statements once again. So this is a very important section. They will ask state and explain superposition theorem. So first you have to write this slide, that is superposition theorem is applicable only when there are more than two waves that are traveling through the medium at the same time. Here we make two assumptions, that is the waves are linear and they are traveling without any disturbance. Then write this statement, that is this one along with this expression, and after that you can write this one, the one that is underlined, that is if these waves are having same frequency, same amplitude, and if they are traveling in same direction, then the final the amplitude of the resultant wave will be twice the amplitude of the individual wave, and this occurs only if the waves are in phase. If the waves are out of phase, then there will not be any motion, that is, it will be a motionless situation. That is enough. Then now these motion of waves can produce two type of phenomena, that is, one is standing wave and the other is beat. So what is when is a standing wave produced and when is a beat produced? So we will see that if the two waves are of same frequency and amplitude traveling in opposite direction, then you will have a standing wave or stationary wave. That is, one wave is traveling like this. Please note, it is having same frequency and amplitude. Okay, one wave is traveling to this side. Now another wave, a similar wave, is traveling in the opposite direction. It is also having uh, the same frequency and amplitude. Okay, they are also traveling in the opposite direction. So two waves of same frequency and amplitude but traveling in opposite direction, that will give rise to a standing wave or stationary wave. Okay. Now another point is the standing waves. We know they are called so because they are stationary, that is, they are confined to a region, that is, it will not, there is no further movement, it is confined to a region, and hence there is no flow of energy. Okay, so that is a standing wave. Now in a standing wave, at certain point, that is in a standing wave at a distance of half a wavelength apart, you can see certain points which are permanently at rest. Those points are called nodes, and some other points which are midway between them with the maximum displacement are called antinodes. So in the standing wave you can see certain points, that is nodes and antinodes. You can see nodes where at half a wavelength apart, it is at half a wavelength apart in a standing wave, you can see certain points which are permanently at rest. They are called nodes. Okay, and midway between them there are some other points which are at maximum displacement. Those are called antinodes. Okay, so here when you are asked to write about standing waves, you have to write how it is generated and also you have to mention about nodes and antinodes. Okay, so what is standing wave and how is it generated? So when you get a question like that, you have to write standing waves are stationary waves, that is, they are confined to a region and there will not be any flow of energy. They are produced when two waves of same frequency and amplitude travel in opposite direction. Okay, then and then what are nodes and antinodes? That is, in a standing wave at a distance half a wavelength apart, there are certain points which are permanently at rest. They are called nodes, and those points with maximum displacement and which are midway between them are called antinodes. Okay, hope you got the definitions. Then next is what is meant by beat. That is another phenomenon. It is produced when two waves of same frequency travel along same path in the same direction. So same frequency, same path, same direction. Then a phenomenon called beat occurs. So what is meant by beat or how does it occurs? Then you have to write beat is produced when two waves of same frequency travel along the same path in the same direction. So same frequency, same path, same direction. Then you will get beat. So note the difference. That is, standing wave is produced when two waves having same frequency and same amplitude travel in opposite direction. But how is beat produced? When you have two waves of same frequency traveling along same path in the same direction. Okay, so the type of generation is different for both standing wave and beat. So today this is enough. So here you have to go through intensity of waves and give more importance to superposition theorem. Okay, superposition theorem, and I have explained how to write. Then standing wave, notes, antinodes, beats. About beats, you will have to study in detail, that we will deal in the next class. Okay, thank you.